Welcome back to part two. We are at the bottom. The page number in your notes is 123. It's actually the second page in your notes. We're now going to talk about real world function rules. And in the last video, I actually ended up on this part right here where we were talking about it's printed right above the problem. When you graph a real world function, you need to choose an appropriate interval for the units, and then every interval on the axis should represent the same change value, which they did that on this graph that they show you on this page. Based on the data, you'll notice that the y-axis increases by 500 each line, and by 50 each line on the x-axis, or what they call g here. Well, let's read what this question is about and see if we can apply this real world and see what the variables are doing here. It says this function rule, W equals 8g plus 700, represents the total weight. Okay, so that's one of the variables, the weight in pounds of a spa that contains g gallons of water. So our two variables are gallons of water and weight. So basically, it says what's a reasonable graph of the function rule if the spa is 250 gallons, and they want us to build a table to represent the whole thing. Anyway, so think of it like this: that the total weight, okay, the weight depends on the gallons of water that are in the spa. Now that would make sense if you think about it. If you have this big container that holds water, the more water that you put in it will increase the weight. So the weight depends on how much water is in there. So weight, that's going to be your dependent variable. That's just why they put weight here. And the number of gallons, that's what you can control. Whether or not you put more water in there, you can control that. So they want you to build the table based on that information. If gallons is 0, which is what this 0 means right here, we are going to figure out, well, what is the weight? Well, the weight would equal to 8 times 0 plus 700. And 0 plus 700 would be 700. So at 0 gallons, the weight of the container or the spa would be 700 pounds. So that basically means that the spa weighs 700 pounds with no water in it. All right, and then if we ask ourselves, well, what would it be if we had 50 gallons of water? It would be 8 times 50 plus 700. Now you can do that math on your calculator and double check me here. That's 550 is gallons, and that works out to be 1,100 pounds, I believe. Again, double check me and let me know if that doesn't work out for us. On the third one, it would be 8 times 150, and then you add in the weight of, whoops, there's only 700, not 7,000. The weight of the spa is 700. 8 times 150 plus 700, that would work out to be 1,900. So the order pair would be 150, comma, 1,900. And then the last one, we would do the same thing, and I'll go ahead and show you. That works out to be 250, which was the gallons, comma, 2,700 there. All right, now it says graph the order pairs on the coordinates of the right and connect the points with a line segment if it would make sense to connect them. We'll talk about that in a moment. Well, let's plot these points. 0, 700 is the first one we have. So here at 0, that's 500 right there. So you've got to go just a little bit above the 500, which I'm guessing would be about right there. The second point, 50. All right, so this would be 50 right here because this is 100, so 50 would be halfway there. Up to 1,100 would be slightly over the 1,000. 150, there's 100, there's 150 for gallons. Again, gallons, 150. 1,900 would be slightly below the 2,000 at 1,900. And then 250 is right there, and that would be 25, just a little bit over that right there. And then we wanted to get a straight edge again, and it said to connect it, but let's consider, does it really make sense for us to connect that line? Well, is this data discrete or continuous? Consider. Is it possible to have half a gallon? Is it possible to have 3/4 of a gallon? Okay, we're going to talk only about values above 0, of course. Could you have any number in between these points that we plotted? See, we plotted these these 4 points, but we have to ask ourselves, does it make sense that there are other values that could exist in between these points? Well, of course, you could have 100.5, 102/10. So this data is continuous. So yes, you should connect the points because the data is continuous. If that data were not continuous, we would not connect the points. That's the whole point of identifying whether or not something is discrete or continuous. It's all based on the independent variable, which is on the x-axis. In this case, it's called G for gallons of water. And that's what they talk about on this page right here. If you have continuous data, you would connect the line. Okay, that is continuous. This data on the right for number 12, that's called discrete, because the discrete data has breaks in it right there. So there are some values in there, like remember the oranges? We wouldn't sell half an orange. That would be discrete data there. Okay, the last thing I'm just going to fill in for you here, and that is this last problem, number 13, 14, and 15. They gave you an equation, W plus 3T, and they ask you to fill in, and it asks you also, is this continuous or discrete? So if weight, okay, is 3 times T, basically what you're doing to T, which is time, what you have here is you have a bathtub filling up. Okay, 1 times 3 would be 3, so they gave you this equation. 2 times 3 would be 6, 9, and 12. If we plotted those points at 1 time is 1, 3, 2, 6, and 3, 9. Okay, while the pool is filling, okay, the water will enter throughout an entire given minute. The graphs on the points should be connected by a line because we could have half a gallon, a third of a gallon, a fourth of a gallon. The graph is continuous, so we would want to draw a line to represent that data right there, and that would make sense to do that. And I'm going to call that good for video 2. I think that's enough information for today. So finish up those notes, review anything you don't understand, and we'll see you in class.